Part 2. Welcome back. This section we're going to cover NFPA 99 2012. To get started, we're going to cover a couple of vocabulary for healthcare in general. The first one is patient care vicinity. NFPA defines patient care vicinity as a space within a location intended for examination and treatment of a patient, extending 1.8 meters or 6 feet beyond the normal location of the bed, chair, table, treadmill, or other device that supports the patient during examination and treatment. And this area also extends vertically 2.3 meters or 7 feet and 6 inches above the floor. Our next vocabulary that we need to know is wet procedure location. This is the area in which a patient care room where a procedure is performed that is normally subject to wet conditions while patients are present, including standing fluids on the floor or drenching the work area, either of which condition is intimate to the patient or the staff. This includes surgery suites. And when we're working in a wet procedure location, they typically couple that with a isolated power system. And this affects us because we cannot perform an electrical safety test on an isolated power system, because an isolated power system has an isolation transformer and a line isolation monitor that is ungrounded conductors. So, in essence, a isolated power system is not grounded like a normal device. It has 2 hot ungrounded conductors and then the earth connection for the isolation transformer. The transformer itself is not connected to ground like a normal class 1 device. So I do invite you to watch the video about isolation power systems in MSARU. In an isolation transformer, the windings or ungrounded. All right, another thing that is specified in NFPA 99, it talks about strain reliefs of a power cord. The strain relief, it protects the cable from tension and stress and prevents it from breaking at the connectors. So as you see over here in the photos, we have different types of strain relief that are commonly used. The strain relief will often, it can be connected to the base of the connector and then have a stem. This is just to prevent damage. But over time, when we visually inspect, we need to really look at that and document that in our work order when we do our visual inspections. Grounding conductors, this is talking about the ground wire in the power cord. The grounding conductor shall not be smaller than 18 gauge. The grounding conductor of a cord longer than 4.6 meters or 15 feet shall not be smaller than 16 gauge. And a grounding conductor in the power cord shall not be required for double insulating appliances. So class 2, a grounding conductor is not required, but a functional ground conductor shall be permitted. One thing to know when we talk about the AWG number, the gauge number, the smaller the AWG number, the thicker, larger the wire. So a 16 gauge can accommodate an appliance with higher wattage than an 18 gauge. Connector is built such as the grounding prong is the first to connect and the last to disconnect. So if we have to rewire a cord cap, this is an image of a cord cap, and there are hospital grade cord caps. They are designated with a green dot, and oftentimes hospital grade is stamped on them. When we rewire one of these, if we have to for an emergency situation to get a customer through, we always want to order them a power cord to follow up, because replacing the entire power cord is the best thing. But if we have to wire this cord cap onto a cord, then you will need to make the green or ground wire in that just a couple millimeters longer than the hot and the neutral, And you want to make sure also that you've got this cord cap tightened down on the insulation. If you have wires showing, then you'll have to cut it back and rewire it again to make sure that when you close it up that it is on the insulation and not pressing down on those wires, creating another hazard. All right. They classify equipment in a facility as either fixed, where it's wired into the facility power supply, or portable, where it has a detachable power cord and it's not hardwired. Okay, there are different tolerances for fixed equipment. Now, first off, fixed equipment that is permanently wired in the patient vicinity shall be tested prior to installation, while the equipment is temporarily insulated from ground. So you do your initial check-in leakage test before it's wired up, and then the leakage current flows through the ground conductor in the power supply connected to ground of a permanently wired appliance. Shall not exceed 10 milliamps. Now, this is milliamps, not microamps, with all the grounds lifted. If we needed to test this afterwards and not unwire it, then we could use a continuity test using our Pronk safety analyzer or a multimeter. Common devices that are hardwired into the facility are your surgical lights. Now, they used to actually hardwire blanket warmers into the facility, but that's a practice that has gone away. All right, for portable equipment, you have the grounding 3-prong power cord is what they want you to have, and then you can have double insulated appliances. It's really important to do a physical inspection of the power cord, making sure there's no cuts, wires showing, or damage to insulation. All right, moving on to talking about resistance. So when NFPA 99, they specify certain tests, as we've already discussed, with limits. But for the ground cord resistance test, they do want it to be less than 0.5 ohms. But when you're doing this test, you should be flexing the cord at the connector, at the wall connector, and then at the machine connector, because those are the places that'll wear out. And what we're looking for when we do that flex is, are we seeing the numbers jump high and low while we're flexing that cord? If it's going above the limit, then we have an issue that we may need to, it may be time to just replace that power cord. So also, you will do this test before you do any leakage test, because you've got to have a good grounded outlet and a quality cord to get proper leakage for some of the tests. For leakage current testing, NFPA 99 requires that we turn it with the power switched on and with the power switched off. Once again, we have to do our resistance test, our protective earth test, resistance test first before conducting any leakage measurements. And also, we shall not be making any measurements on the load side of an isolated power system or isolated transformer. And the reason for this is that the leakage test current will be erroneously low, the readings will, so you may not, and there's no adjustment for that. So we could have a device that's over tolerance, over the limit, and just not know it because the readings will be low. So to measure something that's in a surgical suite, look for an outlet, because if it's a newer suite created, they may have a grounded outlet in there for that purpose. Otherwise, we would need to either remove the device and move it to an area where we can test with a grounded outlet, or we would need to let the facility know that we're using an extension cord to test, and that we will be sure to remove that extension cord when we leave the work area. Now, this is for future reference anyway, because when we start working in standalone surgery centers. Now let's move on to touch leakage test procedure. Touch leakage procedure is the measurement shall be made using a circuit with the appliance grounded and broken in two modes of the appliance operation. The power plug connector in normal with the appliance on, and the power plug connected normally with the appliance off. So test it with the power on and the power off. Now, patient leakage, this is where we check the leakage between all patient leads connected together and to ground. Shall be measured with the power plug connected normally on the device. The leakage current shall not exceed 100 microamps for ground wire closed and 500 microamps for ground wire open. Thank you for watching. Please join us in part 3, where we will discuss the test definitions for the electrical safety test.